So first kind of memory device we classified as read-only memory, that is ROM. Here in this ROM, we cannot write data in read-only memories. It is a non-volatile memory, that is it can hold data even if power is turned off. So generally this ROM is used to store the binary codes for the sequence of instructions you want the computer to carry out, and data such as lookup table. This is because this type of information does not change. So it is important to note that although we give the name RAM to static and dynamic read-write memory devices, that does not mean that the ROM that we are using are also not random access devices. In fact, these most ROMs are accessed randomly with unique addresses. So the given figure is the structure of a ROM. So it consists of a bit line and a word line. It consists of a transistor T and a switch P. The transistor T is driven by the word line. The content of the cell can be read from the cell when word line is logic 1. A logic 0 is read if the transistor is connected to the ground through switch P. If switch P is open, a logic value 1 is read, and the bit line is connected through a resistor to the power supply. So a sensing circuit at the end of the bit line generates the proper output. The data is stored inside the ROM circuit. So this inside the ROM circuit. So there are 4 other types of ROM. This ROM is further classified into 4 types, that is masked ROM, PROM, EEPROM, and EEPROM or E square ROM. So next one is the PROM. So PROM is the abbreviation of programmable read-only memory. These PROMs are programmed by the user. To provide the programming facility, each address select line and data line intersection has its own fused MOSFET or transistor. When the fuse is intact, the memory cell is configured as a logic 1, and when fuse is blown, the open circuit, the memory cell is logic 0. So this is represented in this diagram. Logical zeros are programmed by selecting the appropriate select line and then driving the vertical data line with the pulse of high current. So this is the working of PROM. This is a circuit of 2:4 decoder PROM. So it has it has diodes in every bit position. Therefore, the output is initially all zeros. Each diode, however, has a fusible link in series with it. By addressing the bit and applying proper current pulse at the corresponding output, we can blow out the fuse, storing logic 1 at that bit position. The fuse uses material like nichrome and polycrystalline. For blowing the fuse, it is necessary to pass around 20 to 50 milliamps of current for a period of 5 to 20 microseconds. The blowing of fuses according to the truth table is called as the programming of ROM. The user can program PROMs with a special programmer. So it is this programmer is called as PROM programmer. This programmer selectively burns the fuses according to the bit patterns to be stored. This process is also known as burning of PROM. The PROMs are one-time programmable. Once programmed, the information stored is permanent. So this is the how we program the data inside the PROM logic. And next comes the EEPROM. So EEPROM is nothing but erasable, programmable, read-only memory. So the structure is given here. Erasable programmable ROMs, it uses mask circuitry. They store ones and zeros as a packet of charge in a buried layer of the IC chip. EEPROMs can be programmed by the user with a special EEPROM programmer. So as like PROM, the EEPROM also has a special programmer. The important point is that we can erase the stored data in the EEPROM by exposing the chip to the ultraviolet light through its quartz window for 15 to 20 minutes. So it is possible to erase selective information. When erased, the entire information is lost. The chip can be reprogrammed. This memory is ideally suitable for product development, experimental projects, and college laboratories. So this chip can be reused many times over. So this is the working and how we can able to reprogram the erase the data in the EEPROM. So the programming in EEPROM involves different processes. So when erased cell in the EEPROM contains 1, data is introduced by selectively programming zeros into the desired bit location. Although only zeros will be programmed, both ones and zeros can be presented in the data. So during programming, address and data are applied to the address and data pins of the EEPROM. When the address and data are stable, the program pulse is applied to the program input of the EEPROM. This program pulse duration is around 50 milliseconds to its amplitude depends upon the EEPROM IC. So it is typically the amplitude ranges from 5.5 volt to 25 volt. So in EEPROM, it is possible to program any location at any time, either individually or sequentially or at random. So the next type of ROM is EEPROM, which means electrically erasable, programmable, read-only memory. So in this EEPROM involves the erasing of the data using the electricity. So this uses mass circuitry very similar to that of the EEPROM. Data is stored as charge or no charge on an insulated layer or a insulated floating gate in the device. This EEPROM allows selective erasing at the register level rather than erasing all the information, since the information can be changed using electrical signals. The EEPROM memory also has a special chip erase mode by which entire chip can be erased in 10 milliseconds. So this is the internal logic of ROM. So it consists of n input lines and m output lines. Each bit combination of the input variables is called an address. Then each bit combination that comes out of the output line is called a word. The number of bits per word is equal to the number of output lines, which is denoted by m. The address specified in binary number denotes one of the minterms of n variables. The number of distinct addresses possible with n input variables is 2 power n. An output word can be selected by a unique address, and since there are 2 power n distinct addresses in ROM, there are 2 power n distinct words in ROM. The next one is PLA. So PLA is a programmable logic array. The ROM, PLA and PAL are the various forms of programmable logic devices. They all belong to single family called programmable logic devices. These devices can be easily configurable by the individual user for specific application. Also, the combinational circuit do not use all the minterms every time. Occasionally, they have don't care conditions. So this PLA is similar to ROM in concept. However, it does not provide full decoding of the variables and does not generate all the minterms as in the ROM. The PLA replaces decoder by group of AND gates, each of which can be programmed to generate a product term of the input variables. In PLA, both AND OR gates have fuses at the inputs, therefore both are programmable. This is the structure of PLA, and it consists of n inputs, output buffer with m outputs, m product terms, m sum terms, input and output buffers. So these are the structure of input and output buffers. And then the RAM, it consists of internal memory of the CPU for storing data. Further, it can be classified into static RAM and dynamic RAM. Thank you.